Hello everyone. In today's session, we're going to discuss about Maxima commands related with functions. We know that a function is a mapping which relates one set with another set in such a way that every element of domain will have unique image in codomain. Now, how we are going to define a function? We define a function using the assignment operator colon with equal sign. Colon with equal sign is used to define a user-defined function. Suppose if you give f of variable x1, variable x2, etc. up to variable xn is equal to assignment operator colon with equal sign and any expression, this command will assign the expression to this function f of x1, x2, etc. up to xn. Or you can use the command define f of x1, x2, xn, etc. expression within the braces. This also used to define a function. We can use any one of them whenever we have to define a function. Now, the next command is display function, disp function of all. So this command displays whatever the user function that we have defined are listed out or displayed. So this command disp function of all displays all the user defined functions. We'll see some examples to understand these commands. Now after this, we are having how to remove a user defined function. We have to use a command rem function of the function, say function 1, or you can use kill all. This also kills all the user defined functions, or kill particular function funct1. So this kills or removes the user defined function funct1. And how you are going to define any anonymous function? To define any anonymous function, we use the command lambda. Lambda within simple bracket. Now here we have used a square bracket. This square bracket is used to define the variable list. Variable x1, x2, etc. up to xn, expression 1, expression 2, etc. up to expression n. So this defines use anonymous function expression 1, expression 2, etc. up to expression n, depending on x1, x2, etc. up to xn. The next command is how you are going to assign any particular values for a expression. For that, we use apply in bracket. We write this command lambda. For example, I have taken two variables, say x1 and x2, one expression 1, and we are giving the value for variable x1 and x2. We are evaluating expression 1 at x1 equal to a1 and x2 equal to a2. So this returns the value of the function, that is expression 1, by applying x1 equal to a1 and x2 equal to a2. Now, how can we map a value to any expression? We use the command map. Map a function or expression, say expression 1. We want to find the value of this expression at a1, a2, etc. up to an. So your expression one will be assigned at a1, a2, etc. up to an, and same values are returned. Now how to find how to declare the functional dependencies? So to declare the functional dependencies, we use the command depends. Depends within simple bracket. For example, if there is only one function, you don't have to write a list. You don't have to use the square bracket. Simply you can write funct1 And if there is only one variable, you can write funct1 comma var1, variable 1. Or if there are two functions, you have to use list, that is square bracket, funct1 comma funct2 comma, if there is only one variable, you don't have to use the square bracket, simply you can give var1, or within square bracket also you can write var1. If there are two variables, we can write var1 variable 2 within simple bracket. If there are three variables, var1 var2 var3. Like this you can declare whether the functional dependencies. So this returns the list with the function 1 depending on variable 1, variable 2, variable 3, comma, function 2 depending on variable 2, variable 1, variable 2, variable 3. So like this you can use this command while computing the derivatives. Now, how to find the composite function f composition g of x? You have to give f of g of x. This returns the composition function f composition g of x. And to find the composite function g composition f of x, you have to give g of f of x. So these two commands gives us composite functions. Then how we are going to verify whether the given function is an odd function or even function? We know that a function is even function if f of, you replace the variable by negative of that variable. Here I have used x, so I'll replace x by minus x, and in the function f of x, so I'll replace wherever x is there that by minus x. Then your f of minus x, if it is equal to f of x, then the function is even. If f of minus x gives you minus f of x, then the function is odd. So we will verify using the command is within simple bracket f of minus x equal to f of x. Then this returns true. If this returns true, then the function is even. If this returns false, then the function is not even. If this returns true, then the function is odd. If it returns false, then it is not odd function. So using these commands, we'll try with some examples in Maxima platform, and we'll see all these examples in the Maxima. Let us see these examples in Maxima. The first one is write the following using assignment operator command. The first one is f of x equal to x square plus 2x plus 3. Okay, let's write as usual. We start with kilol. I don't want to display this, so I'll put a dollar sign. It's always better to start with kilol, so that earlier predefined or user defined variables or values will be deleted. Now we'll assign the function f of x using the assignment operator, that is colon with equal sign. Remember, colon is also an assignment operator, but it is used to assign any particular value to a temporary variable or user defined variable. Now here, to define, you should always remember that to define a function you have to use colon with equal sign. F of x equal to x square plus 2 into x plus 3. I want to display this, so I'll put a semicolon after this. They've asked you to find f of 2. Okay, let's find f of 2. I want to display this, so you have to use semicolon. After each executable statement, you have to end with either semicolon or dollar. If you use dollar, output will not, it will be executed, but output will not be displayed. If you use semicolon, the executable statement will be executed and output will be displayed. After f of 2, we have to find f of pi. How we are going to give pi? It's a built-in function. So, as we learned earlier, we have to give f of percentage pi. Then we have to define a command. We have to define a function g of x comma y. So here we are using two variables with assignment operator, and we have to write square root of x plus y. How are you going to write square root? Yes, sqrt of x plus y. We want to display this. I'll use semicolon. Then see, if you press enter, it will come to next line. Don't use shift enter, just use enter. Then we want to find the value of g at 4, 5. Give a semicolon. So we have written all the functions which are there in the example 1. Now we will execute this using the keys shift enter. See, what was your first function? F of x. Yes, f of x has been assigned and displayed because we have used semicolon. Then f of 2. So it will find value of the function at 2. That means x will be given with value 2. So give x equal to 2. So this takes 2 square 4 plus 2 into 2 4 8 plus 3 11. So this is your value of the function at x equal to 2. Similarly, value of the function at pi, it takes pi square plus 2 pi plus 3 because it has given x equal to 3. Now if you use float command or dot 0, what happens? Dot 0 is not an infix operator, so it will not take. So what I'll do, I'll use the command float. If you use the command float, what happens? It calculates, it simplifies. If you don't use the command float, simply it retains, see, pi square plus 2 pi plus 3. Similarly, g of xy is a function assigned with square root of x plus y. And what is the value of g of 4, 5? Give x equal to 4, 4 plus y equal to 5, 9. Square root of 9 is 3. That is what it has displayed. Now the next example is, write the following using define command. Okay, let's use the define command. We knew how to define them. So I'll write kill all to kill all the earlier user defined values. Now we have to define what was our first function. Yes, it is f of xyz is equal to what was your f of xyz? X square plus y square plus z square. Okay, so let's define it. As usual, function f with respect to variable, yes, x, y, z, and what is your expression? X square. So you have to give x cap 2 plus y cap 2 plus z cap 2. Then after this, what do you have to find? We have to find f of 1, 2, 3. So f of 1, 2, 3. Okay. Then we have to define another function. Define g of x, y, z, w. Okay. Using 4 variables with square root of, the expression is square root of x plus y plus z plus w. Then after this, we have to find g at 0, 1, 2, 3. Let's find them. After writing this, press shift enter. Okay, see, this is another way to define a function. We have defined f of x is equal to x square plus 2x plus 3 using the assignment command. Similarly, you can use define command also to define a function and to find value of the function at given point. See, instead of this, we can write like this also. F of x, y, z colon equal sign with x square plus y square plus z square. What it gives? See, these two are one and the same. So either you can use colon with equal sign or define command to define any function. What is the next command? The next example is remove the function using remove command f of x and g of x, y, z, w. So we have to remove them. Okay, let's remove that. As usual, we start with, okay, don't kill, because I'll keep these functions itself, and from this I'll remove f and g, f of x and g of x using the command remove function. Remove function. What do you need to remove? F. Okay, let's remove f. Now you see, using the command display function all, what it gives you? See, it has removed all the functions defined f. See, f was here, f was, because you have used kill all, it has killed all these two, right? So it has kept only f and g, only these two. Now here it has removed f, so it is showing only g. Now I'll remove g also, and let's see what happens. Remove function g. So now it has removed g. Let's see what are the user function that are left out. Display function. It is showing empty because earlier it has removed f. Now it has removed g, so nothing is left. So it is showing you empty. This is how you can remove a function. Next example is using the lambda command. Define the following. First one is log x plus log y and find the value of f of a comma b. So if you assume this is your f of xy, then you have to find the value of the function at a comma b using anonymous command, anonymous function, that is lambda. Okay, let's kill all the earlier defined results. Kill all. Okay, so we have killed all the results which were defined earlier. Now after this we'll write lambda. Okay, so within lambda, first we need to define the variables. So it is log x plus log y. So there are two variables are there, x and y. After this we need to write the expression. What was your expression? Log x plus log y. Log x plus log y. Right? Now see what happens. Now it has defined lambda of this. Okay. Now we'll find the value of f of a comma b. f of a comma b. Or otherwise what we do is we give a and b here itself, and we'll see. Yes, now it is taking. So this gives you value of the function log x plus log y at a comma b. Then the next example is sin x plus cos y plus tan xz, and find values at p, q, r and 102. Okay, let's find out them. So as usual, we'll define lambda. First, okay, so let's use one more time kill all, so that it kills all the user defined function lambda. Okay, so what are the variables? X, y, z. Three variables are there. And what is your expression? It is sin x plus cos y plus tan xz, tan x into z. Okay, straight away we can give at p, q, r. Otherwise we'll see whether this will work or not. Lambda of this f of p, q, r. No, this is not taking, so let's give here itself at p, q, r, and let's see. Yes, see here, it has assigned the value for the expression. It has evaluated the expression at p, q, r by giving x equal to p, y equal to q, z equal to r. Similarly, we'll copy this and we'll paste here, and we'll find that 102. See, it has it has assigned x equal to 1, y equal to 0, z equal to 2. This is how you can write an anonymous function using lambda command. Now using the next one is using apply command, find the value of pqr for the function sin x plus cos y plus tan xz. So we have to use apply command. What is that? Okay, let's write kill all. Okay, you kill. Then we have to write apply. Now let me copy the same thing, lambda of this. Okay, you have copied. Right, after copying we have to find the value of this at p, q, r. You have to give within the square bracket. I use the semicolon. See, these two are one and the same. So either straight away you can give like this using this command, or using apply command you can apply pqr for this expression. Now the next example is using map command, find sin x at x equal to a, b, c, d, e, and cos x at x equal to 0 and pi. Okay, let's see. As usual, we'll give kill all. just to kill all the user defined function. Now the next one is map command. Now I'll write lambda, and I'm having only one variable, so let me give this one as x, and the expression is sin x, and we have to find this at a, b, c, d, e, right? So we have to find the value of sin x at x equal to a, x equal to b, x equal to c, x equal to d, x equal to e. So your answer will be sin a, sin b, sin c, sin d, sin e. Okay, let's see. See, so it is giving you a list. At x equal to a, the value of the expression is sin a. At x equal to b, the value of sin x is sin b. It's a sin e. The next example is, I will copy down the same thing. Next one is cos x. Cos x at 0 and pi. What is cos 0? 1. What is cos pi? Minus 1. So it is evaluating cos x at 0 and pi. So you can find the value of, or you can assign the value, or you can find the value of a function for multiple values using the map command. The next one is the use of depends command. So write using depend commands, u depending on variables x and y. Okay, so as usual I'll give kill all. Then we had to use depends command. So your depends, u depends on, what are the variables? U depends on x and y. Okay, u depends on x and y. The number of arguments must be even. So here there is a mistake. It is not even. Okay, let's do one thing. Let's put this in square bracket and let's see. See, you can give square bracket here also, there is no problem. So it gives you, or it declares the functional dependency of u on x and y. So it gives you u of x, y. Now the next one is, what is next one? Your f and g depends on x. Okay, depends f and g on x. See, it gives you f of x and g of x as a list. And the next one is depends L and S. Okay, L comma S on U, V, W. Oh, mismatched parenthesis. Okay, here it is missing. Okay, so this is how you can use the depends command. And the next one is, if f of x equal to, let me write kilon okay, let me call f of x. What was your f of x? Using this command, square root of x, sqrt of x. Okay, what was your g of x? g of x is sine of x. Okay, then what we have to find? We have to find f composition g of x. We know that f composition of g of x is given by f of g of x. And how you are going to find g composition of f of x? G of f of x. And how you are going to find f composition f of x? It is f of x. How we are going to find g composition g of x? G of x. Okay, let's find. See, what is your f of x? Root x. What is your g of x? Sin x. What is your g of x? Sin x. What is your f of g of x? See, first it will evaluate according to the Bernoulli's rule within the parenthesis. Within the parenthesis, first it will evaluate g of x. What is your g of x? It is sin x. So, it takes f of sin x. Here f of x is square root of x. So, in place of x you are having sin x here. So, what is your f of sin x? It is square root of sin x. So, that is what is giving square root of sin x. Next, g of f of x. First it takes f of x. What is your f of x? Square root of x. So, this becomes g of square root of x. But what is your g of x? Sin x. But in place of x you are having square root of x. So, it gives sin of root x. That is your g of f of x. What is your f of x? What is your f of x? Square root of x. So, it takes square root of x. So, what is your f of square root of x? In place of x, it gives square root of x. So, square root of square root of x. Square root of square root of x. X to the power of 1 by 2 whole to the power of 1 by 2, which is x to the power of 1 by 4. What is your g of x? Your g of x is sin x. So, this is g of sin x. But in place of x, it takes sin x. So, sin of sin x. So, this is how it evaluates. Okay. The next one is how to verify the given function is odd or even. Okay. The first one is f of x. Okay, let's write down f of x. What is your f of x? It is x square. So, x cap 2. What is your h of x? It is x cube. Okay. What is your k of x? Yeah, your k of x is cos x. What is your last function? G of x. Your g of x is sin x. Okay. So, I have defined the functions. Now, I'll verify whether your f of x is odd or even. Is f of, we know that f of minus x equal to f of x. And the function is odd or even. Yes, in this case is even. So, similarly, is f of minus x is minus f of x. This will verify whether this is odd or even. If this is true, then this is odd. If this is true, then it is, if this is true, then it is even. If this is true, then it is odd. Similarly, let me copy down this. Let me replace for h. Okay, I've written for h. If this is true, then it is even. If this is true, then it is odd. Okay, let me give a write for k. Let me write for g. You can write each of them separately, or you can write as a whole, as I have written. Now execute them using shift enter. Now see here, your f of x is x square, h of x is x cube, k of x is cos x, g of x is sin x. is f of minus x equal to f of x. True. That means this is a even function because minus x whole square is x square itself. So your f of minus x is f of x. This is not odd, so false. Next one is h of minus x equal to h of x. False. This is not odd, a even function because minus x whole cube is minus x cube. So minus will come. That's why is h of minus x is equal to minus h of x? Yes, true. So it is an odd function. Then next one is k of minus x equal to k of x? True. Why? Because cos of minus x is cos x. So k of minus x is same as kx. So it is an even function. True. Is that right? Okay. Then is k of minus x is minus kx? No, false. The last one is g of minus x equal to g of x? Sine of minus x is minus sine x. So this is not true, false. Therefore this is not even function. Is g of minus x equal to minus g of x? Yes. Sine of minus x is minus sine x. So it is an odd function. So this is how you can verify whether the given function is even or odd using Maxima command. At given certain exercise, you work out and write them as assignments. Thank you.